we can keep track of the motion of the mass while it is oscillating. The mass begins at its highest point, with maximum extension, then moves down to the equilibrium point, zero extension. It continues down to its lowest point, maximum negative extension, and turns around and returns to its starting position. The mass has completed one full cycle of oscillation. The displacement of the mass from the equilibrium position is described by a cosine function. At any point in time, we can calculate the displacement of the mass. The displacement depends on the amplitude of the oscillation, x max, the phase, phi, which is the initial starting point chosen, and the angular frequency, omega. We can also keep track of the velocity of the mass. At the start of the motion, the velocity is zero. It speeds up to its maximum velocity, as it goes through the equilibrium point, then back to zero as the mass turns around to go in the other direction. Then it has maximum velocity again, but in the other direction, so we say this is negative velocity. This produces a sine graph, so the expression for velocity is a sine function. Lastly, let's think about the acceleration. Acceleration is defined as the rate of change of velocity. The time when velocity is changing the fastest is when there is maximum acceleration. Remember that velocity has both a magnitude and direction. It is actually when the mass is changing direction that the velocity changes the fastest. Thus, acceleration is maximum when the mass is furthest from the equilibrium point. There is no acceleration when the mass is going through the equilibrium. Acceleration is given by a cosine function,